So in this session, let's discuss about like how to build a neural network using TensorFlow, as well as like we also train it for a simple classification problem. Okay. So before that, what exactly is TensorFlow? TensorFlow is a machine learning framework which can be used for training and deploying like machine learning models. Okay. So most preferably, this is one of the popular like framework which people use, and also apart from that, there is also one more like PyTorch, like which also is one more popular library. But in this session, let's focus on like using TensorFlow and like implement a neural network. Okay. So before that, like while for using TensorFlow, like we have to install it like in our local. So we can do that by creating like going to your Conda environment. So and installing it by pip install TensorFlow. So by doing this, like it will install the latest version of TensorFlow. So in case if you want a custom version, you can do it by pip install equal to. So maybe I want something like 13.1. So you can still do that. Okay. So but latest version of TensorFlow is like 2.3 version, and let's also use the same version for our demo. So like I'm going instead of like using it in local, I'm going to run my like code in like Google Colab, so which doesn't require any Python installation or any other installation. You just have to go to Google Colab and then use it. So let me go to my browser and then open Google Colab. So if you will search, it will come in the first result. So here, let's go to Google Colab. It will actually show you, like I think we have had this introduction of Google Colab in our previous sessions. Please like look into our those videos, like which will be shown in the description for much detailed explanation. So apart from that, like let me create a new notebook, like which will anyway be stored in our Google Drive. So let me create one new notebook here. So okay, it will start creating it. It will look similar to the Jupyter notebook, how we use it in our local. Okay, so let me rename this to a new name. Okay, so TensorFlow tutorial for simple neural network. Let me write NN. Okay, so this is a notebook. So here I'm going to import TensorFlow, which you can do it by doing this way, like import TensorFlow as TF, and let me also import NumPy. So these TF and NP are kind of shortcut names for TensorFlow and NumPy. Instead of writing the whole name, we can just do a short form usage. Okay. So let me, in case you now if you want to check the version of TensorFlow, you can do it by this way. So it has been imported now. Let's see this. So which version is are the Google Colab using? So yes, so it is like 2.3.0. So Google Colab already come with pre-installed TensorFlow version. Mostly they try to update the version to the latest. So this is like 2.3.0 version, which is available right now. So in case we want a different version to be, if you want to use a different version, you can do it by using pip install TensorFlow equal to 1.13.1, maybe in case we want this version. Okay, so but thing is like this is not a Python command. To run this command line command, what we should be doing is keep a exclamation mark before, so which it will treat it as a kind of a command like which you use it in command prompt, and it will execute it. Okay, so I'm not doing it right now. It's just like I for information I have told these things to you. So but like let me for this session I'll be using the same version what it is here. So for this TensorFlow 2.3, like how will we use it? Like initially let's try to create a variable here. So tf dot, how to create is this variable, and then okay, variable, and then like you can give a kind of a random number. Let me create a random matrix here, random, and then give a kind of a shape 3 comma 4. So here I'm creating a variable, like I'm randomly generate giving some data of 3 by 4 matrix, and I'm passing it through the variable. So what this will happen is this will initialize the variable a, Okay, so there is a small little error. Okay, I forgot to keep a bracket over here. Okay, so cool. Now this is fine. So what it will do is it will store this value, this data which was generated by this unpaid at random of 3 comma 4 data. So that is this matrix, and it the where tensor of like a will be stored with the name like variable 0, which will be given by default, and this is the shape which will take the shape of like what data you have initialized with, and also the data type. So here the data is float, so it has given a float. So and in case you can check the type of a as well. And okay, see, it is not a numpy array or something, like it is a TensorFlow variable. So similarly, let me also, in case you want to convert it into numpy, you have to do it like this, a dot numpy. So which will give you the data, and you can also see the type of a dot numpy is a numpy array. Okay, so this is how like you can use the data. So and like okay, so what exactly tensor will do is it will create a nodes. Okay, so and also the graph connection which you will see in further uh, like now like we'll be doing those as well, like while like trying to create a neural network, it will actually create the structure of your graph and nodes, like with which like the computational flow will happen. Okay, so with which like let's also see that now. Okay, so and one more thing, like for before going to all that, let's try to do some metrics operation, and which because like entire your neural networks and other deep learning methods are simply a kind of a metrics operations, right? So let's see a few metrics operations here. So basic, maybe let's discuss only about a simple add, subtract, multiplication, and those things. Okay. So let me create a variable, one more variable. This need not be a variable. You can also create a constant in case if you don't want to vary it and have the same number. So let me copy this from here. Okay. So I'm going to have a similar shape variable, but this time I'll give a name to this, okay, as B. So what will happen over here is if you run it, so previously it has given a name variable to that A, right? So here, because we have mentioned its name is B, so it has given a name B, okay? So and the shape is like 3 comma 4, and it has randomly again generated some values over here, okay? So this is B. So now let's try to do addition of these two. So tf dot add a comma b, because those two are in the same shape, you'll be able to do add. You can even for this as well, you can still specify like name as well and other things like, but as of now let's not do all those. So this is how you can do. And similarly, let's also do a subtract, where you can use subtract and then a comma b. This way you can do a matrix subtraction. Okay. And finally, in case we want to access the data inside that, so this will again be a tensor, right? So in case we want to access it, you can do d dot numpy, and it will give you that value. So and now let's try to do a matrix multiplication. So e equal to tf dot maxmul, and this is a similar syntax what we use for numpy, and here a comma b. Will it happen? Because like A is like 3 comma 4 and like B is also 3 comma 4, right? So but you need something in a shape of like, for multiplying with 3 comma 4, we need like 4 rows, right? Then 3 rows won't be sufficient, so it will give an error. Let's see this now. Yes, as expected, it has given an error. So what we'll do is let's create one more variable e, which again a kind of a random. Let's not spend time in like creating variables. So I'm just taking a random values over here. So tf dot variable, and to this I'm going to create a 4 by 5, let us say, and make it this name as e. And so this is what we are having. Okay, and this is e, right? So we have planning to multiply a and e here. and let me call this F, and let's see what F it. Okay, cool. This multiplication happened, and because A is like 3 by 4 matrix, and this is 4 by 5 matrix, 4 by 5 matrix, so our product will be 3 by 5 matrix. So that is, it came as expected. Okay, so this is how you can do matrix operations. Similarly to this, like there are something like np dot where and other things, right? Like transpose, determinant, and all others. Like just like it is same as like how we used to do in NumPy. Okay, so that's why I'm not discussing those now. So let's jump further in designing like how the neural network would look like. Okay, so for this, like what we'll try to do is we'll let's try to I'm going to refer a TensorFlow tutorial which is available in the TensorFlow website, like which is a beginner tutorial. Okay, so I'm going to use this the code like and explain you step by step what it will do. Okay, so in that, okay, let's go further. So this is a tutorial where they show the classification, where they include build neural network with using images, like taking image as a data set and then train the neural network and finally get the accuracy of model. This is what is included in this tutorial. I'm going to use this tutorial, like explain you step by step what it will happen. So first import TensorFlow, which we already did. And next thing is, this is a minus data set which they are trying to load and do a classification. So let me also write minus classification. And okay, this is a text, right? So let's insert a text code here and let me write that. Okay, so here I'm going to load a data set here. So instead of you downloading it again, so this is available at in TensorFlow library itself, where it contains the URL and from where like we can download the data automatically through the code. So this minus contains those data, and how we can do it is this way, minus dot load data. But this data set actually already has been split, had this train test split, and has been stored in this format. So actually, instead so we are directly using it this way. Instead, in case if it is not stored this way, what we can do is we can actually use an like train split, your scikit-learn's API offers like train test split, and do the split as we like. Okay, so but here, because like it is already used, like we are not focusing on doing this split, because like our main focus in this session is to try to create a neural network and see like how we can use TensorFlow to create neural network and build and train a neural network. Okay, so let's focus on that more. So after this, what we'll try to do is, so minutes data is ready, right? So next part would be something like this. So if there is like some data pre-processing which has been done. Okay, before doing that, okay, let's see like what this data contains. So data dot shape, train dot shape, you can see it is a kind of like 6,000, 60,000 into 2828 is the data set size. So which it means like 28 by 28 is like images, and we have around like 60,000 images which were available for training. Similarly, like we'll have, so if you take this test, so okay, this contains 10,000 images which belongs to test set, and like which will use it for evaluating our model. Okay, so let's see like what this contains. So Y shape is actually a label for these 60,000 points here, the images here. So let's see one of them. Okay, let's try to plot and check, because this is an image, we have to view it, right? So let's view it. So how we can do it is we can do matplotlib dot py plot as plt. Okay, let's use this concept, because if it is just for viewing, like matplotlib would be sufficient. In case we want to do any image operations, we might need like OpenCV. Okay, so but as of now, just for viewing, like this would be sufficient. Let's try to plot one of this image. Okay, so there is this plot.im show where you can give the array of this and then get Okay, I'm going to see only single image. So let me see 0. Okay, plot. See, you can see there is a 5 here. Okay, so it's a handwritten digit of 5. Similarly, let's see what is there in ground truth. Okay, so what actually is being stored in byte. See, it's a 5, right? Similarly, in case you want to see something else, okay, just 10. Okay, I want to see what is there in 10. Let me run it and see. Okay, so 10, there is a 3 here which was handwritten and it was labeled as 3. So our data set actually contains labeling from 0 to 10, 0, 1, 2, 3, 4, so on till 10. Like not 10, it's still 9, right? It's a single digit. So, and similarly, this X train and the X test will contain the images of those handwritten digits. So, this is the data, and you have a 28 by height and 28 width of this image. So taking this, let's think about like how we can create a neural network, and let's design a neural network and then implement it back in Python here. Okay, in step which they have done, and then we can jump on to the neural network part. Okay, so what they have done is like this data actually, like if you see the range of your data point, let's check this only, like as well. So if you see this, what does it contains is like so many numbers you see, like 254 to 116, like 19, 117, so on. So actually your data set will range from like 0 to 255. Okay, so your values of your data set will be in this range. So what we do is like instead of doing it, so instead what we do is we will actually do a kind of a pre-processing so step, like kind of a normalization step here. So we'll try to get all our data points which we use it for train within like 0 to 1, right? So for doing that, what we do is we'll actually like divide this by the maximum number, which was 255. So if you do that, your values now, if you see those values, it will be within like 0 to 10. Okay, let's see that. So see, you can see like all your values are within 0 to 1, right? So now it will be like, because now it is in 0 to 1, now this can be used for training. Okay, so now let's go back and then see like for this data how we can design a neural network. Okay, let's design this network. So how we can do it is, let's try to design neural network. So how we'll do? So what is our image here, like data size here is something like this. So this is a image like data of 28 by 28 is your pixel like images here. So this what we do is like we have to create a neural network. Let me call it NN model. So and it should give an output. Okay. So and this output, what it should do, like what is the idea of this neural network is like get an output value which should classify that image into one of these, right? So because you have something like this, so it should be classifying into one of these class, right? So because like maybe you have some digit like this, so it's 8, right? So it should classify that this is 8, so it should give like 1 here and zeros everywhere else. So if it is class something like this, it's 7, right? So this should give 1 here and zeros everywhere else, so something like this. So that should be our model output. So input, what we do is like this looks like a 2-dimensional, right? So let's flatten this out, like the 2-dimensional, like let's flatten it to a single array, like where this is currently 28 by 28, which is a square matrix, right? So this square matrix, what I am doing is flattening it into one long matrix, so like this. So and what will it means like something sample like this 1 2 3 4. If you have something like this, I while flattening it will become 1 2 3 4 like this. Okay, so the same thing I'm doing it here. So your value will be like 28 by 28, which is 764, I think, right? It adds a 64, yeah, something similar to that. Okay, so this I'm doing it here. So let this be our inputs here.
So this is the input layer, which is 764. Let me recheck if it is 760. Let me calculate and check and confirm if it is 764. Okay, so it's 28 into 28. It is 784. Sorry, it's not 764. It is 784. And now this is the input class, right? So from here we have to design some hidden layers. Let's say we have some hidden layers here, and then again, like if you want, you can add few more hidden layers, and finally we have to have an output layer. So and output layer should be fixed, right? So output is like it should design between like one of these values. Okay, one of these 10. So you have 0, 1, 2, 3, 4, so on. There should be 10 here. This is fixed. Output layer shape should be 10. Okay, this is fixed. So only thing is in between how you have, like how many layers you have. This is a kind of a hyperparameter which we have to tune. Like we have to try some values first and then see like if it is working fine. If it is not working, then try one more, like something like that. So what will happen is like there will be connection, as we have discussed before. So every cell will have like a connection with every other cell. For a we call that as a dense network. So okay, so similarly you have, let us say, have all the connections. Similarly in the next layer as well, you have connection from every cell to every other cell of a layer, every other cell of different layers. So that is how finally your network should look like. So what I do is I'll 4 is an input, and from here let me use something like 128, and this is also given in a tutorial. So let's not deviate from the tutorial, use the same thing, but you are free to use like what you want. And finally, instead of adding few more layers, I'm directly giving this output layer as 10. Okay, so let's first try to compute some layer like this. So this is input, and here it's a dense layer, and finally this is also a dense layer, okay, of which will give you 10 values. Okay, let's first create it, and later what we should do is we should be ensuring that these will give like probabilities, right? Because what it should give is like value. Let's say for one it is 1, and for every others it is 0. That is ideal, but reality what should will happen is it will be like 0 0.9, 0 0.8, something like this, and others will be 0 0.1, 0.002, something like this. But overall, like entire probability, like sum of all the probabilities should be 1. So for getting that value, what we will do is we will add a softmax. After this, what we do is add a softmax. Okay, and by adding a softmax, what we have discussed like earlier, what softmax will do and all. So what it will do is like your entire, like all the classes, it will values it will take, and finally just like this one. So for each class, theta x1 by e power like minus theta 1 x plus e power minus theta 2x plus so on e power theta nx. Okay, so this kind of formula, it will have like this kind of formula. So what this formula will have is like it will ensure that your values are like sum of all your values is 1. Okay, so that is what a softmax will do. We please refer our previous sessions in case we want a detailed explanation. So we'll use the same concept here and add a softmax, so that your final output will have a kind of a probabilities like what we have discussed here. Okay, so this is how we'll be doing it. So let's try now, like let's jump on to the Collab and then try that in code. Okay, so let's so now let's see how we can use it. Okay, so if you can refer this here, like as we have discussed. So we let's use it like how we have decided those numbers. So here, but here let's see this. So initially, like there are like many ways with which we can define the model, but one of them, like which was given here, is like at a time they are combining all the models and adding it here. I'll discuss one other way. So where like you initially discuss like add treat the model as something like this, which is actually an empty model. So to this, like I'm adding a model dot add, and to this, like initially what we had discussed, like we will do a flatten of like 28 by 28 and use it, right? So similarly here as well, so it is done the same way. So for doing that, we have to use this command. So what we have to do is tf dot keras dot layers dot flatten, and then input size is 28 by 28, right? So if you take this, what it will contain is, initially it will be an empty model. Now it has added the flatten layer here, which actually flattens your input of like multiple dimensions to a single dimension. So where now it is a 28 by 28. Now after flattening, it will be only single layer of 164, sorry, 784. So taking this now, next step is to add a hidden layer. For adding a hidden layer, we use a dense, right? So and now we don't have to specify this input shape, because it is only needed at the first place, right? Because we only take data in the beginning to the input layer, we don't need it in the middle. So in the hidden layers will actually be connected to a previous layers, right? So here these will be input to this layer, and let's say there are 128 cells in this, and also to this, let's also give an activation function as relu. So this is how it will be there. Okay, so now this is ready. So to this, I'm adding one more now. So let me keep it the dense layer as 10 and remove the activation here. So, okay, so now what you have is an add and a dense layer. So this is a output layer as we decided, like this output layer contains 10 cells in the final layer. So that is this. So now like the dense layers, like 128 cells will get interconnected to this 10 layers, 10 cells in the next layer. So now let's run it and see like what it gets. So if you want to see, like you can see the model summary. You can see here model summary is like flatten. So this is a like shape, and to this shape, and there is next a dense layer of shape, this one, and these are the parameters, like and similarly the 10, and then this is the parameters. So how did you get this is like you can see this 128 and then 10, right? So these layer, like every 128 cells in this layer will get connected to 10 cells in this layer. So if you take the interconnections, how many will you have? 1280, right? So 1280 connections in total. So to this 1280, again, like these layers will have contain some bias, right? So there will be 10 bias variables again. So 1280 and 10. So it will be 1290 here. Similarly, for this, you have interconnections from like 784 to this 128. So it will be 784 into 128, and again it will contain like 128 variables for bias. So it will be like some as well. So if you take the whole, it will be this value. So in total, your network, which looks like quite simple from the implementation here, will actually contain these many parameters. It has like more than 1 lakh parameters in it. So this is quite huge, right? So what we should do is like but for training it, it wouldn't be so difficult, because just like how we have implemented, it looks quite simple, right? Similarly, TensorFlow has provided a framework for training this model, this huge model, like very similar way. Just like what you have to do is pass like pass the data by using like model.fit, and then get the outputs. Okay, just like let's also refer it here. So in case if you want to pass it now itself, okay, so like before doing any training, in case if you want to pass it, so let's see how we can do it. So before that, let's also see, like just like this is done, like let's also do the same thing. So here they are passing a single so like this may be confusing for you, like let me do a simple show here. So what it is doing is, so it is, so let's see the shape of this. So it is one image of 28 by 28 size. So this one image is being passed to this now. Okay, so let me do this and use it here. Okay, so now let me have this. So here what I am doing is I am passing this as input to the model and getting the output. So that will be a prediction, which is the last layer output. So I expect there is 10 outputs here. So let's see what you get. Okay, you see these are like randomly given. So initially it will, because you did not like have any trained it anything, like it just gives some random values over here. So and you can see the sum of it doesn't look like probabilities, right? Because there are negative numbers and this sum doesn't look like one. So what we can do is like just as we discussed before, we have to add a softmax layer to this. So and what we do is something like this. So tf dot softmax, like the softmax implementation is here. So if you do prediction like this, so what we get is something like this. So if you see here, so most of the ones are like having like very less probability, right? So but some of probabilities, like you can see, this is not confident at all in predicting, right? So mostly it's giving very low scores. So even though if you can take like maximum score from here, so which is this 0 1 2 3 4 5, it means like it is predicting it as 5. So let's visualize this actually, like if it is 5. Okay, for visualization, like this looks like a 3D shape, right? So for getting, we should only take, so it is actually 0th element. So let's see what the actually is y train for it. The ground truth one, ground truth is actually 5, and surprisingly we got 5 here. So but actually we should really train in and get it, like because like this is not very confident, right? So it was saying only 0.16. So what we should do is like let's try to train it again and then see like how we are getting. Okay, so let's go forward after doing pretty. So that is a kind of a coincidence what we got, but usually it wouldn't be uh, set value. Okay, so because let me for checking, let me see something else. So let me put, instead of 0 to 1, let me put third one. Okay, and run it. Okay, you got some values, and then prediction you got some values which contains higher value at 4. Okay, so let's see what it contains. It is showing 5. Okay, we are kept like 3, right? So we should put 3. 3 is 1. It is wrongly detected as it is wrongly detected as, oh, we can also do something like argmax, which will actually give you the predicted value. Okay, we did not install import numpy as np. Okay, see now what it has given is a 3, but in reality it is ground truth is 1, so it did not predict it well, right? So what we should do is we have to define a loss function, and through that loss function what we should do is actually train the model and optimize it. So this is one loss function, which is like Keras has implemented loss functions internally. So this is one of them, where it is sparse categorical cross entropy loss. So which we use it for kind of a classification. So here let's use this and see like how will. So now like you have just defined a loss function, right? We did not actually tag our inputs and outputs to it. So we have to link this to our what you say like loss like model here, that we do it by this form. Okay, what we do is model dot compile, and the defined loss function you add it here. Okay, so and also a matrix, like with what matrix you want to show. It can be this, or you can also add loss as well, and these like you can see it. And optimizer, you can there are like various optimizers like which we'll discuss in a different session. So you can actually use that optimize, like one of those optimizers, gradient descent or like rms prop. There are like many others. Okay, so adam is like one best optimizer technique, like which like actually does very good way, like, okay, so we are using RDM optimizer. So the implementation is there internally, you just have to specify the name, it will automatically take. So and once you do that, you just have to do this thing. Okay, model dot fit x train y train, and then to this we have to do like epochs, which were like 5 epochs. So I'm running it for 5 epochs, so it's running. So see epoch 1, and here it is showing the number of iterations. Okay, so it will by default take some batch size, because we have 60,000 examples, right? So 60,000 it was taking like by default, what is it, some 40. Calculator, let me take a calculator and see. 60,000 divided by 785. So it was taking 32 as a batch size. At a time, it is taking 32 like data points, and it is training the network. So you see, like it is being trained. Like epoch 1, your accuracy is like 92%, and going to epoch 2, your accuracy is like 96, 97, 98, 98.5. So it has increased like very well, right? So it was coming close to 100. So like this is like pretty decent. Like as of now, like let's say like this is satisfactory one. Okay, this has got very good accuracy. Now let's try it on the test set, because these accuracy which we have seen now are actually accuracies on the train set. Now let's see on the test set what it is. So for that we do it like model evaluate. So we can use this. So and we have this test and like y test being already there, right? So we use this when it is running. It doesn't run like epochs, right? Because it is test, like it doesn't modify the weight, so it will be same always. So again, like it will run batch wise here. So and for that batch, this is a loss like 0.07, which was okay. Like here, like loss of training loss is 0.04, and here it is 0.07, which was decent. Okay, like it's not very bad. So because like if you take initially it is 0.26, and it decreases to 0.04. And similarly here now loss is 0.707, it is fine. So and similarly accuracy is 0.97, which was here it is 0.898, and here it is 0.78, right? 978, right? So this is fine, right? So this is not bad at all, like it is doing very good. You can anyway tune like these values here, like dense values, like you can change this value or like add one more layer to this, and finally maybe improve this accuracy much better. So of each, right? So this softmax, just like how we have thought earlier, we have to add a softmax to it. So let me do that. Let me call the probability model. So where what I'll do is I'll take this, just add the model here. So let me so what they have done, it is similar to like what we did before, but for this model what we have defined already, they are adding one more layer. Okay, so we can also do the, just like model dot add, but before that what I'm doing is, so let's try a different way. So see if it will work. So I'm creating an empty value here. I'm calling it a probability model. So this is not actually required like doing two differently. We can directly would have implemented it over there. So for this, I am adding a model. So directly I'm adding the whole part like what it has been trained till now. Okay, it also holds the weights, right? So what it has trained. So taking this now to this, I am now adding softmax layer, what we have discussed before, right? So to get the probabilities and so on, like we are doing this now. And let's see the summary as well. Okay, you see, so this is a sequential layer. It is a combined one where you finally have outputs like this, and then to it I am adding a softmax. So these are the parameters, right? So this is how it is. Okay, so now what I'm doing is, let me, because now it is already trained, so I'm trying, I don't have to do any loss function again, all those things, just like I'm adding a softmax to it. So to this, here let's see only one image. Why do you want to see all at a time? So I'm going to pass only a single image, like which is a test 0. So if you run on this, so it has given some values, out of which we need to take the maximum one. So the maximum one is here, which is like 0.9, which is like 9 into 10 power minus 1, which is like 0.9, and the rest are like very low numbers, right? So in case if you want the value directly, what you can do is np dot argmax. So argmax will actually give you the value. Like if you want the probability, you have to take the probability of it. So let me do this way. So this is the probability also how much it is. So you can check it by seeing that argmax. So how we'll do it is, this is a kind of a tricky. So instead of making it too complex, let me say that index equal to, okay. So and then I'm saying that array here, okay. So I'm printing both probability as well, and index actually is a digit, and that will actually give you the probability. Okay, so let's see. Wow,